This is the first of two lessons on volume that we're going to do. So in this lesson, we're going to look at volume of prisms and cylinders, and then in the next lesson, we're going to look at some other shapes. You need your formula sheet for this. Everything with volume for us is going to be based on the formula, so it's really a matter of identifying the shape, finding the formula. In a few cases, figuring out which numbers you're using can be a little tricky, something you have to think about, but hopefully for the most part, this is straightforward. So the first thing that we're going to do is just look at some of these shapes and sort of identify them. And often, I mean, a lot of these are going to be easy. But when we actually have to do some questions with them, as I said, especially for the triangle ones, sometimes it's a little bit tricky to figure out which numbers you're supposed to be using. But we'll get to that when we start doing some examples. But it's interesting to look at all of these shapes all at once and recognize the different dimensions that you can have. So we've got three options. We can have, there's two kinds of prisms. Okay, so we're going to look at rectangular prisms and triangular prisms. And then we're also going to look at cylinders. So again, the cylinders are pretty easy to recognize. And I'm just going to use a C for the cylinder. So that's a cylinder. That's a cylinder, and that's a cylinder. This one's lying on its side. The other two are standing up. This one's wide and kind of flat. This one's taller. So again, you can see the different kinds of dimensions that they can take, the different forms that they can take. Okay. This shape over here on the left is a prism. It's a rectangular prism. Now, it's a prism because it has two surfaces that are equal, that are the same, that are connected by rectangles. Rectangular prisms are unique in that every side is a rectangle. So, which side is the base doesn't really matter. And that's not actually something we really need to get into, so I'm not going to spend a lot of time on it. But that is how you identify any kind of prism. It has a base shape, and then it has two of them that are the same, and then it's connected by rectangles between those two shapes. So here's one that's standing up. Here's another rectangular prism that's lying down. Those two look very similar. One's standing up, one's lying down. The other thing about these is sometimes people worry about, well, what's the length, what's the width, what's the height? Because if it's standing up, then you think that's the height. But if it's lying down, you think that's the height. And it doesn't really matter what you call which one. There are certainly cases for other shapes where it matters. For rectangular prisms, it doesn't really matter much. In particular, not for this course. This is not something that we're really going to have to worry about. So don't overthink which one's the width and which one's the length. That generally speaking isn't going to matter. Okay, here is a third rectangular prism. And that one's very different. It doesn't look like the other two. And again, it just shows, I always think that looks kind of like a cereal box. And it just shows that these things can take very different forms. Okay, we've got two shapes left, and you can tell they're both triangular. So are they triangular prisms? And they are. This one has a base shape of a triangle, and here's one triangle. And here's the other triangle. Right? So you can't see two of the sides because they're at the back, but this is the other triangle. And so those two triangles are equal, and then they're connected by, take a look, that's a rectangle. Okay, and there's a rectangle on the bottom and a rectangle on the back as well. And again, when we start to look at some examples of these and when you do some practice, you'll get to sort of think through what the different sides look like. So this is a triangular prism. Okay, and the last one is definitely a triangular prism as well. We can see the triangle in the front, and then we can see this square. Well, it looks like a square, maybe it's a rectangle, is one of the sides, and this rectangle that kind of looks like the bottom is another side, and there's a triangle on the back. But take a look at how different these two look, right? The two triangular prisms. They're very different looking, and so these can definitely take different forms and look very different. if we were exploring this further and doing things like surface area, that kind of stuff, which we're not doing, these can get very tricky. But for us, we're going to keep it simple. We're not going to spend a ton of time on this. Okay, so let's get into it. We're just going to do one example of each, and we're going to find the volume of each figure. As I said in the opening, this all comes down to the formula sheet. So, if you want to break this down into steps, the first step is identify the shape and find it on your formula sheet. So I'm going to flip over to the formula sheet. This is the same one that we were using for perimeter and area. That was posted for that. And notice that the second page, if you print it out, and you can print it out front and back, that might not be a bad idea. Second page has the volume formulas. Okay, and notice that it's got cylinder. I don't know why it's in this order. No idea. It's not alphabetical. It's not really the order that we do it in, but that's what it is. And then at the bottom, it's got rectangular prism and triangular prism. And again, similar to perimeter in particular, but area as well, there are multiple versions of these formulas. So you want to pick which one you want to use and maybe cross out the other ones. So the first example that we're doing is a rectangular prism. So I'm gonna look at this one, and I notice that there's this that's supposed to be a formula, but it's not actually a formula, it's just words. Now again, if this is something that we were exploring deeper and spending more time on, this is something that we would talk more about and explain. And it may certainly be something that you've seen before, where for any prism, you can just find the area of the base and multiply by the height. But for us, this actually isn't going to really help us that much. So I think we can kind of ignore that for now and stick with the straightforward formula, which is volume equals length times width times height. Okay, so if I go back, and again, a lot of people are probably going to think that this is the length and this is the width. And I don't know about you, but I mean, I do kind of have this feeling in the back of my mind that the length is always the longer one and the width is always the smaller one. That's not a rule. So that's not something that has to be true. But it might be the way that we think about it. But this is what I said before. In the end, it doesn't really matter. Okay. So I'm going to write down the formula: length, width, height. And off to the side, I'm going to write out these values. So length is 7, width is 3, height is 12. Again, people would, I think, all kind of agree that that's the height because this figure is standing up in that direction. But if I lay the figure down, does that mean the height would change to the 7 or the 3? In our minds, it would, but that doesn't change the shape of, or the volume of the figure, right? So which one's length, width, and height doesn't really make a difference is what I'm saying. So just don't overthink it, okay? There's nothing wrong with doing it the way that makes sense to you and thinking of it that way, but don't overthink it. You don't have to do this. It's kind of overkill for a question like this because, I think this is pretty straightforward, but this is a strategy of writing out your values that works, that can be very useful later in mathematics when things start to get harder. For this, you don't have to do it. So this is substitution from, I think, lesson 2 of the course, where, and I said this when we went over it, that this is going to come up over and over and over and over again, and it has. And here it is coming up at the very end of the course again, where I've got length times width times height, and I'm subbing in. Now, be careful. This is a common mistake where people don't sub with brackets like they're supposed to, and people don't recognize that it's length times width times height. Again, we don't use that multiplication symbol that looks like an X anymore because we use X as a variable so often. So that becomes confusing. So we start just writing the letters side by side, but it means multiply. And you need to know that. Sometimes what people do is they just write 7, 3, 12, and then they think that's a number like 7,000. But that doesn't make any sense. So be very careful and do it the way that we talked about substituting in the very beginning of the course, where you put brackets in place, right? So I put brackets like this, empty brackets for the length, for the L, the W, and the H, the length, the width, and the height. And then I take these numbers and put them into all the brackets. Okay. Then I pull out my calculator and I just do 7 times 3 times 12. So again, this is really about the formula, using the formula, doing the substitution correctly, figuring out what the shape is, what the formula is, what each side is to put in the right spot, and then just putting it in your calculator. And this one is meters, so meters cubed. Okay, this will be something that on the test you have to be careful of. You have to include units. It doesn't say it on this sheet, but we talked about this when we did area and perimeter. It did say it for that lesson, but I said, it doesn't always have to say that. It's not always going to say that. You always have to do it, though. That's definitely a rule for us, that you always put in units in your answer, okay? And your units have to be correct. So if it's perimeter and it's just a length, then it would be meters. If it's area, it would be meters squared. If it's volume, it's meters cubed. Okay. Next one. So again, we have to identify the shape. And this is, you can tell it's triangular. It has a triangle base on this side and on this side. And it's a prism because, take a look, it's got a rectangle there. It's got a rectangle at the back. And it's got a rectangle on the bottom. And it's worthwhile taking a minute or so, especially in the lesson and maybe while you're doing the practice with a few different kinds of shapes, to spend some time either outlining them the way I did or just thinking about where those rectangles are and noticing them. We're not going to get too deep into this, like I said before. So for us, it's not going to make that big of a difference. But I think it's still really important to visualize what the different sides look like and where they are. And that's something that, again, later in mathematics, it might be more important. So this is a triangular prism. Back to our formula sheet. There we are. Again, I don't think that version of this formula is going to be that useful. This one's got a fraction in it, which means probably most people want to avoid that. And that one is going to be maybe the most straightforward. So base times length times height, and then divide it by 2. So that's probably the formula that we want to use. If you don't spend some time going through these lessons and getting used to the formula sheet and doing the practice and getting used to the formula sheet, when you get to the test, you might be confused by the fact that there's multiple formulas and start mixing them up or something like that. So that's, again, why doing this in advance lets us cross things out or circle the one that we want to use or whatever it is that you choose to do, but also just get used to them. Now, the one thing I want to point out, again, for us, because we're keeping it simple, it's not going to be super relevant. It's not something you really need to worry about, but the rule is the base and the length have to be at a right angle to each other. So this triangular prism in this formula sheet is not a right triangle. So notice how it shows the base is one of the sides of the triangle, and then the length is through the triangle, right? And it shows the little right angle symbol there to show that it's at a right angle. And that's because for triangles, that's a rule that that the base and the length have to be at a right angle to each other. In fact, this is kind of interesting. And again, I don't want to confuse anybody, or I don't want you to start overthinking things. But when we go back to the formula for area, it says base times height divided by 2. So this is the height of the triangle. And again, it's at a right angle to the base. This is the base, and the height is at a right angle to the top of the triangle, right? So hopefully that kind of makes sense. The same thing is happening here, where this is the height of the triangle, but this is the height of the prism. So again, these ones can be tricky because you might think of them as having two different kinds of heights. I think, again, for us, we're not going to get into any of the tricky kinds of questions. So really, you're going to be given 1, 2, 3 measurements, 1, 2, 3 that are needed for the formula. So you can just use the ones that are given, but there is more complicated ideas involved if we changed up the shapes or started asking some trickier questions, that kind of thing. So volume equals base times length times height, and that's length of the triangle. And actually, this is a really good idea. And then divided by 2. This is a really good example for what I'm talking about. Base, length, height. This looks like the height. And you could think of it that way. It is the height of the triangle. But this is the height that matches the one that we were just looking at in the formula sheet, because that's the distance between the two triangles. Let's go back. This one, the prism is standing up. So notice that that's the distance between the two triangles. This is like a similar prism, but it's lying down. So again, your brain might say, but that's a length, not a height. And what I'm trying to say is that's not necessarily the best way of thinking about it. In the end, again, for a question like this, it really doesn't matter what you put in where. You're going to get the same answer and you're not going to lose marks. But I think it's something that people, if they start to overthink it, they can start to confuse themselves and second guess what they're doing, and that can cause problems. So I'm going to put in let's fill those out first. We'll call 3.6 the base. We will call 7 the length, just because it matches the formula sheet. But if you don't like that, you can do it the other way. You could call this 22. You're going to get the same answer. And the height is 22. Now I put this in, 3.6. And again, right, I'm going to do that. So empty brackets. The L is going to go in there, and the H is going to go in there. If I said L was 22, and I put that in there, and I put 7 in there, it wouldn't change the answer. So I'm going to do it this way, but the order that you multiply two numbers doesn't matter. So it's not going to change the answer. So again, we'll pull out the calculator. 3.6 times 7 times 22 divided by 2. And I get 277.2, and this is centimeters cubed. Okay, and last one, we're just doing one of each. So this is clearly a cylinder. This one does highlight the one thing we have to think about when we talk about cylinders. So let's go back to our formula sheet again and find cylinder. It's at the top. This has 2 options, area of the base times the height. So let's get rid of that one for now. And let's look at this one. Volume is pi times r squared times h. So again, if you didn't know this formula, it would be hard to figure that out when you're writing a test. So you want to have the formula sheet handy and available to you while you're writing the test. Even if we were writing this in class, you would have a formula sheet in front of you. I'd give you one for the test. And you just look up the formulas when you need them. Okay, and we remember the different parts, what the pi means, what the r means, what the h means. The diagram can help you. If you forget what any one of the letters means, the diagram can tell you what the r is and what the h is. But, you know, that can be a little bit tricky. So this is just something, again, like anything, you want to practice and work your way through so that you are comfortable and familiar with it. So pi is not a variable. We don't have to write it. I'll write these in green on the side. You don't have to write this down, but as a reminder, I will put it that it's 3.14. What's r and what's h? So h is the height. I think that one's straightforward. It's 9. And then obviously a common mistake, and a lot of you are going to catch this, but if you're rushing or if you haven't thought of this in a while, you might miss it. People are going to think that r is 8. Well, why is that wrong? Because that is wrong. Because 8 is the diameter. And the radius is half the diameter. So the radius is 8 divided by 2. And, you know, 8 divided by 2 is probably something you can do in your head, but if it's not, if you don't know 8 divided by 2, or if the numbers are bigger or nasty because they're decimals or something like that, use your calculator. So the radius is 4. And then we plug these in. So pi is 3.14 r squared h. Whoops. R squared h. Okay, r goes in here. H goes in here. Again, go to our calculator. 3.14 times 4 squared times 9. So you, depending on your calculator, it might not look exactly like this when you put it in, but that's again part of practicing. And when you're doing the lessons, you should be doing this a lot, not just sitting there watching, but you should be doing these questions on your calculator at the same time as me, making sure that you can get the same answer, which in this case is 452.16. If you don't get that, then you got to keep trying until you can get the right answer in your calculator, or, send me an email and ask, and then we can go over it, right? And I can help you figure out how to use your calculator. But one way or another, you need to be able to do this. You don't want to get to the test and then say, oh, my calculator is different than yours. Can you show me how to use it? During a test is not a good time to do that because we're busy, and it's not the right time to do that. It should happen before. You can also do this on a calculator like this. And this is why, we recommend getting a decent calculator. These ones go on sale for $10. If you keep your eye on Staples or Amazon, they go on sale for $10 sometimes. So like a few times a year kind of thing, you can find them, and it's usually $20 or $30. So that's a really good deal. And it's a really good calculator because you can type it in exactly the way it looks on your page and just hit equals. And this one is centimeters cubed again. And so we're done. Okay. But again, no matter what, you got to figure out how to type it in on your calculator. So that's it. Quick lesson. We did one of each of the 3 types and just talked a little bit about the different shapes, looked at some of the little tricky things that you might see. You will notice when you go through the practice that there are very different looking triangular prisms. And so, you got to practice them to get used to the different ways that they look. Some people are very visual and it's just going to make sense to them. It's going to be easy. And then some people are less visual and they kind of have to think about it to figure out what side is what. Okay. So, you got to take the time to do that. And then looking at a cylinder and noticing the difference between diameter and radius, and making sure that you're not rushing. Because I think everybody you've seen this before, and everybody kind of knows that there's a difference between radius and diameter. But if you're rushing on a test, you might forget to do it. You might just miss it because you're rushing, right? So you wanna make sure you've practiced that enough that you really got it and won't forget it. But that's about it. So go ahead and start the practice. Make sure you try at least several of each kind of shape. So a few cylinders and hopefully a few that are different, maybe some that give you the diameter and some that give you the radius. The triangular prisms, I would do all of them. I mean, you should do all of the practice anyway, but the triangular prisms are tricky. So if you only do one and you skip the other ones for whatever reason, that you might really miss out. The rectangular prisms are all pretty much straightforward. You're given 3 values and you're generally speaking just multiplying them together. So those ones are going to be simple and probably the easiest. That being said, because they're the easiest, they're fast. So you might as well just try them and again get used to the idea of how you write out your answers, plugging it into your calculator and writing out the answer with units. Check your answers in the solutions or at the bottom of the page to make sure that you're getting the right answers. And the last thing I'm going to close with is showing your steps properly, right? We said this before. I want to see writing out the equation, showing the substitution, and then your final answer. Now, sometimes you might want to do more steps, and we talked about this before, so I'm not going to get it into more detail right now, but you may want to show more steps, and that's okay, but you need at least those 3 steps. You cannot just write down the answer. You will lose marks on a test for that. You got to show some of your work. Okay. And that's it. So good luck with practice. And again, next lesson will be volume of some different shapes. And they're, they're a little bit trickier. There's no real tricks to them, but they are a little bit more complex shapes, kind of like the cylinder. So hopefully you've got this nailed by the time we start the next lesson, and we can move on to those other shapes.